the overview, it has been provided or expresses the magnitude of the normal force. So force Newton per unit area given in terms of meter square. It is in terms of meter square applied on the surface. So I have shown you surface in the previous lecture, and here we people are applying a force over this particular surface. Now, depending upon what content we are using, whether we are using liquid, whether we are using gaseous, or whether we are using solid, that force will be exerted on the area. Okay. So at this instant, at this particular instant, units has been provided over here for your references. Now, here P suffix A, P suffix A is equal to Newton per meter square, PSI, LBF per inch square, then bar is equal to 10 raised to 5, Pascal is equal to 10 kilopascal, millibar is equal to 100 Pascal is equal to 1 H Pascal, atoms 101.3 kilopascal, then mm of Hg or torr in mm of Hg. For every unit, H unit is equal to hecto unit, which is equal to 100 units. So all these are nothing but these are the different units that has been used for the force measure, pressure measure. Now here, while measuring pressure, we have to take some consideration or some points under consideration. What are that particular points? That is PABS, absolute pressure, we have to consider. Then we are supposed to consider atmospheric pressure, that is the standard I have provided in the lower line. And PG or P gauge is nothing but the gauge pressure. So these are the common parameters or the notations that are commonly used. Now, static and dynamic pressure. What is static pressure or what is dynamic pressure? As in the first lecture only, while studying characteristics, we have studied static characteristics, we have studied dynamic characteristics. So similar aspect is used over here. Only the reference is of the pressure. Static, slowly weigh. Dynamic, instantly weigh. For provided input. But how it is correlated with your static pressure? So static pressure is nothing but it is the pressure on the fluid or the gases that are stationary one, or it is not providing any motion. Similar to that of our definition of a static. Static is, though you people are applying a force, then and then also you people are getting very slight change with reference to that of input which has been applied to you people or that particular content. So static pressure is in the similar manner. Dynamic, we people are saying he is dynamic, she is dynamic. What it signifies? They respond to the input that has been given to them instantly. Some are slower one, that we are providing the input, taking follow-up, then they are responding for that particular input. So that is static one. So static pressure is the pressure of the fluid or gases that are stationary or not in motion, means still condition, standing condition. They are not providing the motion or variation. But case is not similar to the dynamic one. So dynamic pressure is the pressure that is exerted by a fluid, or a gas when it impacts or when it reacts on a surface or an object in case of a solid. due to its motion or a flow. Due to its motion or a flow means when that fluid or when that gases or when that solid, their contents are in terms of a motion, they will impact or they will exert a pressure. Okay, so in pressure measurement, actually, here we people are having whatever I was specifying in the previous mean. So here actually sea level and all that things are represented over here. So the lower line, this one is the lower line. This is the perfect vacuum. This is the perfect vacuum. What is vacuum? I will tell you. Then above that one, we are having absolute pressure. And above that one, we are having gauge pressure. And in between gauge pressure and upper to that, that one is the differential pressure. So pressure due to atmospheric condition, gauge pressure at the point of interest, and absolute pressure. So absolute pressure is the pressure that is measured with respect to that of vacuum. So the absolute pressure which is measured, it is measured with respect to that of vacuum, and unit is psi. Okay, so 0 psi. If you observe over here, here is our 0 psi. Now what is gauge pressure? Gauge pressure is the pressure that is measured with respect to that of atmospheric pressure. This one is the atmospheric pressure. If you observe, and this gauge pressure is measured, if you try to observe, this is at the upper side. This is at the upper side of that of the atmospheric pressure. So this is measured with respect to or with reference to that of atmospheric pressure, one atmospheric, one atom. Okay, if you convert it into psi, that will be 14.7. One atmospheric pressure is equal to 14.7 psi. And atmospheric pressure is nothing but the pressure on the earth, pressure at our surrounding, on the earth's surface, due to the weight of gases, due to the weight of gases in the earth atmosphere, that is 14.7 psi. That is 14.7 psi. So these are nothing but, these are the definition of your pressures: absolute pressure, gauge pressure, and atmospheric pressure. So how we people are computing the absolute pressure? Absolute pressure is the addition of gauge pressure plus atmospheric pressure. Gauge pressure plus atmospheric pressure. So the above two figures are for the different pressure scales. Different pressure scales. So suppose find the absolute pressure if a pressure gauge reads 8.3 psi while the atmospheric pressure is 14.7 psi. If you observe this particular aspect, you can easily determine the absolute pressure. Now over here, to resolve this equation, absolute pressure is noted as EBS. This is the notation. And as per our definition, we people are having the summation of atmospheric pressure plus we are having the summation of gauge pressure. So this one is your atmospheric pressure, and this one is nothing but the gauge pressure. So you people can easily determine the value. So over here, if the pressure gauge reads 8.3 psi and atmospheric pressure reads 14.7 psi, you are supposed to place that particular value. So what is the value? 14.7 is your atmospheric value, and 14.7 and 8.3 is your gauge pressure value. If you add this one, you are going to get a absolute pressure, and that is nothing but 23 psi. That is nothing but 23 psi. So this is one of the example. You can consider different examples from notebook, or you try to solve the different examples from various books, or you can even design your own examples. But if suppose, I would like to give you another example. I am having a absolute pressure is equal to 23 psi, 23 psi, and atmospheric pressure is equal to 14.7 psi. Determine gauge pressure. You can resolve in this particular manner also, or other than that, we are having absolute pressure is equal to 23 psi, and your gauge pressure is equal to 8.3 psi. Determine atmospheric pressure. So likewise also, there will be large number of combination, and you people are going to get why I have taken same example I would have been given. You resolve by your own to determine that particular value, because the resultant output in these cases, whatever example I have told to you people, that is going to result the same answer. Okay, so likewise, you people, you are supposed to keep in mind that absolute pressure is equal to atmospheric pressure plus your gauge pressure. So you can easily determine, suppose you are interested to determine gauge pressure, then absolute pressure minus atmospheric pressure. Or if you are interested to determine atmospheric pressure, absolute pressure minus gauge pressure. So the resultant output which you are going to get, that will be